When you have two or more equations, we conveniently call them a system. There are three ways to solve systems of equations. By graphing, which means it is a visual solution. By substitution, which is a solution based in replacing one equation for another. And by algebraic addition. Because equations are represented by lines and these lines will eventually cross at a point, unless they are parallel, the solution to the system takes place when we find the point where the lines meet. The most logical way to find the solution of a system is to plot the equation and read from the graph the coordinates. The coordinates represent the point where the lines meet. Let's begin with this example. Find the solution to the system of equations represented by y equals 3x minus 4 and y equals negative x plus 4. Using a graphical solution, plot the first equation where the y-intercept is 0, negative 4 and the slope, the coefficient of x, is 3. Draw the line. Next, plot the second equation where the y-intercept is 0, 4 and the slope is negative 1. In the graph, the lines cross at 2, 2. This point is the solution to the system represented by the two equations given. Graphical solutions have the drawback that the accuracy of the answer depends on how well you can plot the graph. Some systems may not be as simple as the one we just did. For example, find the solution to the system y equals 2x minus 1, y equals 2/3 x plus 2. Plot the y-intercept and slope. The y-intercept for the first equation is at 0, negative 1, and the slope is 2. The y-intercept for the second equation is at 0, 2, and the slope is 2 over 3. The graph shows the system, and the lines form at a point at approximately 2.3, 3.6. Notice that it is difficult to define points that fall between integers, where exact answers are elusive. To solve this dilemma, there are two other methods that may be used. One method is based on substituting one equation into the other, and the second method involves algebraic addition and substitution. Both are discussed in the next two sections, 5.2 and 5.3. Now let's do the next example. Find the equations of the three lines that intersect at A, 1, 3, B, 6, negative 4, C, negative 2, negative 6, to form triangle A, B, C. We start with line AB, using the slope equation. Negative 4 minus 3 over 6 minus 1. The slope is negative 4 minus 3 equals negative 7. 6 minus 1 equals 5. Or the slope is negative 7 over 5. And the y-intercept is 0, 4.3. Substituting the slope for M and the y-intercept for B, the slope-intercept equation is y equals negative 7 over 5 x plus 4.3. Now line CB. The slope is M equals negative 4 minus negative 6 over 6 minus negative 2 equals negative 4 plus 6 equals 2. 6 plus 2 equals 8. 2 over 8 equals 1 over 4. The slope is 1 over 4. And the y-intercept is 0, negative 5.5. Substituting the slope for M and the y-intercept for B, the equation is y equals 1 over 4 x minus 5.5. Now line CA. The slope is M equals 3 minus negative 6 over 1 minus negative 2, or 3 plus 6 equals 9, and 1 plus 2 equals 3. The slope is 9 over 3, or 3, and the y-intercept 0, 0 is an empty value. Substituting the slope for m and the y-intercept for b, y equals 3x. There is no value for b. The equations for the three lines that form triangle ABC are y equals negative 7 over 5x plus 4.3, y equals 1 over 4x minus 5.5, and y equals 3